You are sitting at a traffic light in the dead of summer, sweating through your shirt, running your air conditioning on maximum and wondering why the air coming out of your vents feels like a warm breath. The sun is hammering your windshield, the cabin feels like an oven, and every second that passes makes you more certain something in your system has failed. And that is exactly the moment when most people make the mistake that costs them the most money. They drive straight to a dealership or a repair shop, explain that the AC is weak, and wait for the script they have heard 1,000 times before. You need a refrigerant recharge. You need a full diagnostic. Your compressor may be going bad. Your system may have a deeper issue. Suddenly, a simple discomfort turns into a $150 service, a $400 inspection, or a repair bill large enough to make you stop asking questions. But what if the expensive diagnosis is the distraction? What if your car's AC is not actually broken at all? What if the entire system is functioning, the compressor is spinning, the refrigerant is circulating, and the real reason the air feels weak is because your AC is not failing. It is suffocating. There is a single component hidden behind the glove box in most vehicles that quietly strangles cabin airflow as it loads with dust, pollen, soot, lint, and microscopic road debris. It costs about $8, takes about 6 minutes to replace in a driveway, and in many cars requires no tools at all. Yet for millions of drivers, it is almost never the first thing they are told to check. That silence is not an accident. It is one of the cleanest little markup traps in modern car maintenance. Today, we are exposing the exact $8 component that dealerships quietly turn into a premium service item, the simple airflow physics that make a clogged system feel like a dying one, and the 6-minute driveway protocol that can make your vents blow dramatically colder and stronger without touching the compressor, without adding refrigerant, and without handing over a stack of cash for a problem that never needed a major repair. To understand how this became such a perfect profit machine, you have to go back to post-war Japan. In 1954, in Korea, Toyota Motor Corporation spun off a company called Nippon Denso, the engineering arm that would go on to build many of the thermal systems, HVAC components, and precision parts that powered Japanese automotive reliability for decades. Over time, Nippon Denso became Denso, one of the most respected names in automotive supply manufacturing anywhere in the world. This matters because most drivers still think of the dealership boss as if it represents some secret superior piece of engineering that only the manufacturer can provide. But in many cases, the part inside that branded bag was engineered and manufactured by the exact same supplier that sells it under its own name for a fraction of the price. Cabin air filters are one of the clearest examples of this packaging illusion. When many drivers walk into a Toyota parts counter and ask for a cabin air filter, they are handed a bag stamped with a Toyota logo and charged somewhere in the neighborhood of $28 to $40. The price feels official, so it feels justified. It feels like precision. It feels like factory quality. It feels safe. But when you open the filter housing on a brand new or relatively new Toyota, especially vehicles like the Camry, the truth is sitting right there in plain sight. Printed directly on the filter itself, often with no drama and no attempt to hide it, is the name Denso. That is where the scam stops being subtle. Because once you realize that the filter inside the factory airbox is literally a Denso filter, the next question becomes unavoidable. If Denso made the original filter, what exactly are you paying for when you buy the dealership version in a Toyota bag? The answer, in many cases, is not better engineering, not better filtration science, not a better fit, and not a superior design. You are paying for packaging, branding, and the assumption that most people will never look behind the label. The exact same Japanese-engineered multi-layer cabin air filter can often be found in Denso's own packaging through common online parts retailers for around $7 to $8. Same supplier, same function, often the same basic material concept. Massive difference in price. That is not a premium for performance. That's a markup for the logo on the plastic bag. And once labor enters the conversation, the gap becomes even more absurd. Because replacing this filter is often one of the easiest maintenance jobs on the entire car. On many vehicles, you open the glove box, release the side stops, drop the compartment down, pop open a small rectangular filter door, slide the old filter out, slide the new one in with the airflow arrow facing the correct direction, close the door, and snap everything back into place. No jack, no sockets, no lift, no compressor evacuation, no recovery machine, no advanced diagnosis. 6 minutes, sometimes less. Now here is why this matters physically, not just financially. Your air conditioning system does not cool the cabin by magic. It cools it by moving air across a cold evaporator core and then pushing that conditioned air through your vents and into the cabin space. If the cabin air filter is packed with contamination, the system can still be generating cold air at the evaporator, but far less of that air actually makes it into the cabin at usable volume. The result is a sensation millions of drivers misread every summer. The AC feels weak, lazy, underpowered, almost warm. Not because the refrigeration loop has failed, but because the airflow has been choked before it ever reaches you. In other words, the system is trying to breathe through a dirty mask, and when airflow drops, your comfort drops with it. That is why so many people spend money chasing refrigerant, compressors, and diagnostics before checking the most obvious restriction point in the entire cabin ventilation path. The dealership knows the branded filter is profitable. The shop knows the average customer is more intimidated by AC systems than by wiper blades or engine air filters, and that fear creates the perfect environment for markup. But once you understand the history, the supplier game, and the simple physics of cabin airflow, the mystery collapses. What looked like a major AC failure starts to look exactly like what it often is: an $8 airflow restriction hiding behind your glove box, quietly turning your summer commute into a sweat box while everyone around it pretends the answer must be more complicated than it really is. To understand why this tiny filter matters so much, you have to understand what your air conditioning system is actually doing behind the dashboard. Most drivers think AC is just cold air coming out of the vents, but the real process is much more precise than that. Deep inside the dash sits the evaporator coil, a compact heat exchanger made of thin aluminum fins and narrow passages carrying refrigerant. When the AC is operating normally, that refrigerant moves through the evaporator at temperatures roughly between 32 and 40 degrees Fahrenheit. At the same time, the blower motor forces the hot air from your cabin across those freezing fins. The heat in that cabin air transfers into the refrigerant. The moisture in the air begins to condense, and the air that leaves the evaporator and moves toward your vents is dramatically cooler than the air that entered. That is the entire magic trick of automotive AC. Not creating cold from nothing, but pulling heat out of the air fast enough, efficiently enough, and repeatedly enough that the cabin environment changes from suffocating to comfortable. But the cooling only works properly if one condition is met. The air has to keep moving in the volume the system was designed for. This is where the concept of delta T comes in, and once you understand it, you start looking at car AC like an engineer instead of a customer. Delta T simply means temperature difference. In automotive HVAC terms, it is the difference between the temperature of the air entering the system and the temperature of the air leaving the vents after it has passed over the evaporator. Toyota and Honda engineers typically design these systems to deliver a delta T in the range of about 18 to 25 degrees Fahrenheit under normal operating conditions. So if the cabin air entering the system is 90 degrees, a healthy system may be expected to send air out of the vents somewhere around 65 to 72 degrees, depending on humidity, fan speed, heat load, and outside conditions. That temperature drop is what your comfort depends on. But here's the part most people never hear from a service counter. Temperature alone is not the full story. Vent temperature and airflow volume work together. You do not just need cold air, you need enough cold air moving at enough force to actually flush the heat out of the cabin. That means the blower motor, the evaporator, the ducting, and the cabin air filter are all part of one airflow equation. If one part of that path becomes restricted, the entire experience changes. And the biggest restriction point in that system, the one almost every cubic foot of blower air must pass through first, is the cabin air filter. That is the quiet dealership secret buried behind all the bigger sounding AC diagnoses. Before the blower can push air across the evaporator and into the vents, that air has to pass through the filter media. When the filter is clean, the blower can move its designed volume, and the evaporator can exchange heat with enough air to keep the cabin cooling efficiently. But when that filter becomes packed with dust, pollen, soot, fibers, insect debris, and urban grime, airflow begins to collapse. In many real-world conditions, a clogged cabin filter can reduce airflow by 25 to 40%. That is an enormous drop. The evaporator coil may still be cold. The refrigerant cycle may still be doing exactly what it is supposed to do. The compressor may be fine. But if not enough air is passing over that cold evaporator, not enough cooled air reaches the vents with the force and volume you actually feel. To the driver, it feels like the AC is weak, tired, fading, or losing its ability to keep up. The system runs longer, the fan feels less effective, the cabin takes more time to cool, and the whole car starts behaving like it is struggling even when the core refrigeration hardware is technically still operating. That is why clogged airflow is such a deceptive problem. People often assume weak cooling must mean low refrigerant or compressor trouble because those sound like real AC problems. But a restricted filter attacks the system from the air side, not the refrigerant side. It reduces the rate of heat exchange that the passenger actually experiences. It can force the HVAC system to work harder and longer because the cabin takes more time to shed its heat load. In practical terms, that can increase the energy demand on the system by as much as 15%, especially in hot urban driving where the car is repeatedly heat-soaked, stopped in traffic, and asking the AC to recover over and over again. So even though the evaporator remains cold, the air delivery feels disappointing because the system is being strangled before it can do its job. Once you understand that, the illusion falls apart. The AC is not always broken. Sometimes the airflow math has simply been sabotaged by a filter that has become a wall. Now, this is where the story gets even better, because modern cabin air filters are not just simple dust screens. The better ones contain activated carbon, and this is the part that makes most drivers realize they have been underestimating the chemistry happening inside their dashboard. Activated carbon is not ordinary charcoal. It is not the same thing as the leftover black chunks from a grill. It is a specially processed material that has been treated at extreme temperatures, generally somewhere between 600 and 1200 degrees Celsius, in an oxygen-limited environment. That treatment changes the structure of the carbon and creates an enormous network of microscopic pores throughout the material. The result is a filtration medium with a massive internal surface area packed into a tiny space. Just 1 gram of properly activated carbon can contain a surface area of roughly 500 to 1,500 square meters. That number sounds absurd until you realize the entire advantage of activated carbon is hidden surface. It is not about thickness. It is about molecular real estate. And that enormous internal surface area is what gives the filter its chemical power. Activated carbon works through adsorption, with a D, not absorption. Absorption means something soaks into the inside of another material, like water into a sponge. Adsorption means molecules attach themselves to the surface of a material. That difference matters. As air passes through the carbon layer, volatile organic compounds, exhaust gases, fuel odors, industrial fumes, and other odor-causing molecules encounter that immense microscopic surface network and chemically adhere to it. Instead of simply slipping through the ventilation stream, many of those compounds get trapped on the carbon surface. That is why a quality-activated carbon cabin filter can reduce a large share of unpleasant chemical odors, and under the right conditions, can remove up to about 90% of certain VOC concentrations from the air moving through the system. To most drivers, it just feels like the cabin smells cleaner as the outside world stops invading the interior every time they sit behind a diesel truck or creep through congested city traffic. But what is really happening is surface chemistry on a microscopic scale inside a replaceable filter element the size of a notebook. The truly mind-blowing part is that this carbon layer is not permanent. It has a finite chemical capacity. Every time it traps gases, odors, and VOC molecules, it uses up a little more of that available surface. Eventually, that internal chemical real estate fills. In normal urban driving, that activated carbon layer can effectively die somewhere around 12,000 to 15,000 miles. In heavy pollution, dense traffic, or harsher environments, that useful life can drop closer to 10,000 miles. And once that happens, the filter may still catch dust, but it stops performing the chemical job that made it special in the first place. It no longer traps gases the way it did when fresh. Odors return. Outside, fumes sneak back in, and worse, once filtration and airflow decline together, moisture and contamination begin creating the conditions for biofilm, bacteria, and mold to accumulate around the evaporator area. That is when the system starts developing that stale, damp, sour smell that so many drivers mistake for old car air. It is not just age, it is chemistry exhaustion followed by contamination buildup. And that is why replacing the right filter on time does not just protect airflow. It protects cooling efficiency, interior air quality, and the cleanliness of the evaporator itself. Once you know the physics of delta T and the chemistry of activated carbon, the cabin air filter stops looking like an afterthought and starts looking like one of the smartest maintenance moves in the entire car. In 2009, in the dense, high-pressure traffic corridors of Osaka, one fleet manager stumbled into a pattern that would completely change how he viewed automotive air conditioning failures. His name was Kei Fujiwara, and he was responsible for a working fleet of 87 Corolla Axios and Crown Comfort taxis operating in the Namba and Umeda districts, two of the busiest urban zones in the city. These were not lightly used commuter cars. These were vehicles spending long hours crawling through heat, exhaust, stop-and-go traffic, and constant passenger turnover, with their air conditioning systems running for extended periods every single day. And over the span of just 14 months, something alarming began to happen. His maintenance team was forced to replace 6 AC compressors across the fleet, each repair costing between $800 and $200 in parts and labor. At first, the failures seemed random. Compressors fail, especially in hard-use urban fleets. That was the assumption. But 6 failures in 14 months across a tightly managed group of vehicles was too expensive and too consistent to ignore. So Fujiwara began looking for a common denominator. The breakthrough came when a Denso field representative reviewed the maintenance histories of the failed vehicles and found the pattern no one had taken seriously enough at the beginning. Every single taxi that had suffered a compressor failure had one thing in common. The cabin air filter had not been replaced in over 18 months. That was the hidden link, not the refrigerant charge, not a mysterious electrical defect, not bad luck, not a manufacturing flaw, a neglected cabin air filter. The cheapest part in the airflow path had quietly become the trigger point for the most expensive failure in the system. That discovery completely reframed the problem. These compressors were not simply wearing out. They were being dragged into failure by a restriction upstream that most drivers, and too many service departments, treat like a minor comfort item instead of a critical HVAC component. The taxis were not dying from dramatic mechanical catastrophe. They were being slowly suffocated by neglect. Once you understand the mechanics, the pattern becomes brutally logical. Every bit of air your blower motor pushes into the cabin has to pass through the cabin filter first. When that filter becomes clogged with dust, pollen, soot, fibers, and urban contamination, airflow begins to collapse. The blower motor has to work harder to force air through an increasingly dense restriction, and that overwork begins to pull excess electrical load from the compressor circuit. Meanwhile, the evaporator remains cold, but not enough air is passing over it to carry that cooling efficiently into the cabin. The driver feels weak airflow and disappointing cooling, so the AC runs longer and harder. The system cycles under strain. The blower labors. The compressor starts operating under increasingly irregular demand conditions, with repeated cycling and voltage stress wearing it down over time. Eventually, the system reaches the point where the expensive part breaks first, even though the cheap part caused the entire chain reaction. That is the cascade of failure. A clogged cabin filter does not look powerful enough to kill a compressor, but once airflow restriction forces every other part of the HVAC system to compensate, the stress moves downstream until something major finally gives way. Fujiwara's response was simple, disciplined, and devastatingly effective. Instead of treating cabin filter replacement as an optional maintenance item, he implemented a mandatory 12,000-kilometer replacement rule across the fleet. No guesswork, no waiting for complaints, no stretching service intervals because the car still seemed fine. Every vehicle got a fresh cabin filter on schedule before airflow could collapse badly enough to begin stressing the rest of the system. The result was immediate and impossible to ignore. In the 18 months that followed, the fleet recorded 0 compressor failures. Not fewer. 0. The expensive repeat problem that had been bleeding money out of the operation disappeared when the cheapest neglected component in the system was finally treated with the seriousness it deserved. That is the kind of real-world proof private car owners almost never get to see. A fleet compresses years of maintenance lessons into a short period because the same systems are exposed to the same harsh conditions at scale. Patterns reveal themselves faster. And what Fujiwara discovered was not just a fleet trick, it was a blueprint for everyone. Now widen the lens, and the story becomes even darker. The U.S. automotive maintenance industry generates roughly $18 billion annually, and a huge amount of that revenue depends on customers not understanding the difference between a root cause and an expensive symptom. That is where the financial incentive becomes impossible to ignore. A technician can charge $150 for a refrigerant recharge, $200 for an inspection, and another $120 for a blower diagnostic, stacking up a $470 invoice for what was ultimately an $8 clogged filter hiding behind the glove box. Why does that happen? Because a cabin filter generates almost no labor revenue. It is fast, it is cheap, it is simple. A compressor, on the other hand, can generate anywhere from $600 to $1,400 in parts and labor depending on the vehicle. One job creates a tiny invoice, the other creates a profitable repair order. And when an industry is structured around billable labor, complex diagnostics, and high-margin parts replacement, the least glamorous solution is often the one mentioned last, even when it should have been the first thing checked. That is the quiet business logic underneath the entire problem. So the real villain in this story is not just dirt. It is neglect multiplied by incentive. A restricted filter weakens airflow. Weak airflow overworks the blower. The blower's struggle increases system strain. The compressor begins cycling under stress. The expensive component breaks. The customer is then sold a dramatic repair as if the broken compressor was the original cause, when in reality it was the final victim in a chain that started with a maintenance item cheaper than lunch. That is why the Osaka fleet story matters so much. It proves that the gap between an $8 fix and a $1,100 failure is not bad luck. It is a sequence. And once you understand that sequence, you stop seeing the cabin air filter as a disposable piece of paper behind the glove box. You start seeing it as the gatekeeper protecting the entire HVAC system from a slow, invisible, and very profitable cascade of failure. Now here's the part that changes everything, because once you understand the scam, the physics, and the cascade of failure, there's only one question left. What do you actually do when you walk outside to your car today? The answer is beautifully simple. You do not start with gauges, you do not start with refrigerant, you do not start by assuming your compressor is dying. You start with a single restriction point that controls the air your system is even allowed to breathe. In most modern Toyota and Honda vehicles, that means the cabin air filter behind the glove box. And the sourcing strategy is just as important as the installation itself, because this is where people get trapped again. Do not buy blindly based on a logo, buy based on verified fitment. Denso promotes its first-time fit cabin filters as OE quality replacements engineered for airflow and filtration, which is exactly why they are such a strong option when available. Public listings also support examples like Denso 454, 5057 for recent Corolla applications, and Denso 454, 5061 for recent RAV4 applications, while fitment for other numbers can vary by exact model year, trim, and market. So the smart move is to use your VIN or retailer compatibility tool before checking out. So here is the driveway protocol, and the reason it matters is because it strips all the mystery out of the process. You're not doing a repair in the dramatic sense. You're restoring the airflow path the engineers designed from the beginning. First, open the glove box and remove anything inside it, because the box needs room to drop. On many vehicles, you simply press the outer sides of the glove box inward to release the plastic side stops, then let the compartment swing downward. On some cars, there may also be a small damper arm on one side that gently unclips. In many common designs, no tools are required at all. The moment the glove box drops, you're staring at the access point most people pay someone else to touch for them. This is where the illusion dies. The job looked expensive only when you could not see it. Once the glove box is down, look for the rectangular filter housing cover directly behind it. It usually has simple side tabs. Press those tabs, pull the cover open, and the cabin filter tray or filter element will slide toward you. Now slow down, because this next step is where smart people save themselves from easy mistakes. When you pull the old filter out, do not just rip it free and toss it aside. Look at the airflow arrow printed on the frame. That arrow matters. The filter has an intended direction, and you want the new one to go back in exactly the same way. Take a photo with your phone before removing it completely. That single photo prevents the kind of tiny installation mistake that turns a simple job into an annoying second attempt. Once the old filter is out, inspect it like evidence. If the pleats are loaded with gray dust, black soot, leaf fragments, lint, and city grime, that is your stolen airflow. If the activated carbon layer looks dark, matted, uneven, or chemically exhausted, that is the part that has been failing silently for months. Denso notes that quality cabin filters use multiple filtration layers and are designed around airflow as well as filtration, which is exactly why a neglected, saturated filter changes the whole feel of the system. Then comes the easiest and most satisfying part of the entire process. Slide the new filter in with the arrow pointing in the same direction as the one you removed. Do not force it. It should seat cleanly. Snap the filter housing closed, lift the glove box back into position, and flex the sides inward again so the tabs move back past their stops. If there was a damper arm, reconnect it. That is it. The mechanical portion of the job is done. No tools spread across the driveway. No trip to the service desk. No waiting room coffee. No fake technical language to make a 6-minute procedure sound like a medical operation. In many cars, the total time really is 4 to 6 minutes from opening the passenger door to closing the glove box again. And the reason this feels so powerful is because you are not just changing a filter. You are reopening the lungs of the entire HVAC path. Now for the part most viewers will remember, because it creates immediate feedback. Once the new filter is in place, start the car. Set the fan to maximum speed, turn the AC on, switch the system to recirculation mode, and let it run for about 3 minutes. This is not magic, and it is not a hidden dealership trick. It is just system recovery. With the airflow restriction removed, the blower can now move air through the cleaned pathway at something much closer to the volume the HVAC system was designed for. The evaporator can finally exchange heat with a proper mass of air again. The vent stream should feel stronger, the cabin should cool faster. And within the next few minutes, many drivers notice the output feels sharper, cleaner, and colder, simply because the system is no longer being choked before the cooled air reaches them. Denso explicitly frames cabin filters as part of the air conditioning system and emphasizes that proper airflow and filtration matter to HVAC performance, which is exactly why this before and after difference can feel so dramatic. And this is where future-proofing comes in, because the real win is not replacing a bad filter once. The real win is making sure you never let the system fall that far behind again. Denso's published guidance recommends replacing the cabin air filter at least once a year, roughly every 10,000 to 15,000 kilometers, or according to the vehicle schedule. That interval gets even more important if you drive in urban congestion, dust, high pollen regions, construction zones, or traffic heavy with diesel exhaust. In other words, if your car lives a normal hard life instead of a perfect one. Do not wait for the air to smell stale. Do not wait for the fan to feel weak. Do not wait until you're sweating at a red light in July wondering whether your compressor is dying. Put the interval on your phone. Make it routine. Because once you understand what activated carbon does, what airflow restriction steals from delta T, and how cheap it is to restore that path, neglect starts to look irrational. Toyota engineers got the airflow math right. Denso and other OE-grade suppliers built filters around that airflow reality. The weak link is not always the compressor, the refrigerant, or some mysterious buried failure inside the dashboard. Very often, the weak link is the one piece of maintenance almost nobody respects until it is dirty enough to steal comfort, efficiency, cabin air quality, and eventually money. That filter is the line between engineered performance and the hot, stale air you have slowly been trained to accept as normal. And now you know how to take that performance back in minutes. But here's the real teaser, because this is where the story gets even better. Restoring airflow is only the first half of the war. Next comes the hidden enemy living on the wet side of the system itself, the mold, the biofilm, and the sour evaporator contamination that can survive even after a new filter is installed. In the next video, we are going to break down the low-cost maintenance step people keep getting wrong, the chemistry behind evaporator odor, and the tiny preventive habit that can stop that stale AC smell before it ever colonizes the system. After that, the 6-minute filter swap is going to feel like the beginning, not the secret.